So alright, today's video on LSB encoding is more or less going to be an educational video. However, towards the end of this, I will provide a practical example as well as a test if you guys wish to follow along and maybe decode the image I'll host on my website. With that said, those of you unaware of what LSB encoding is, it's short for least significant bit encoding. Essentially, an image is comprised of 3 pixels, red, green, or blue. And if you're wondering, you can do the same technique to audio as well, but we'll save that for a future video. Anyway, the idea is we pick one of the 3 colors for the pixels to manipulate, and we slightly tinge them or dull them out. Essentially think of it as zeros and ones, so a slightly dimmer red is a 0, a brighter red is a 1. And we manipulate the image in such a way that we can hide data within those pixels. Essentially, the change is going to be so small, if you were to hold 2 of the same images up side by side, the human eye can't tell the difference. However, there are many programs that can, and when you attempt to do an encoding method like this, with most of the more modern programs, there's a method of PGP encrypting the image or adding a key and lock to it. We're not going to be doing any of that. This is just purely putting the data within the image. The data can be anything from text to a file. But with that said, let's get on with the example. As you can see here, I have a picture, a requirements text file, an encode, and a decode Python script. Essentially, this requirements file is what you're going to need to install through Python in order for this all to work. And I believe there's only one dependency that you'll need, and that is pillow. If you're wondering how to install a Python pip package or just how to get Python in general, check out my video from a few videos ago. I go in depth explaining how to set up a Python virtual environment as well as how to install packages. But with that said, since I don't have a virtual environment made for this project, I'm going to go through the effort of making one right now. Don't take this as really a tutorial. Like I said, be sure to check out my last video on how to set up a Python virtual environment if you want to get into this really deeply. For now, I already have Python installed. You can get that at multiple different ways. If you want to know, check out the video from before. But yeah, all I'm going to do is type in Python -mvenv, and let's call this LSB-env for my virtual environment, I suppose. That will now make a Python library here within our projects directory. And if you're not in your projects directory, a simple way to do this on Windows is to shift right click in your folder. And on Linux, usually you can just right click in your folder and hit open terminal here. And that will open your terminal or your console right into the directory where these files are at. So now that Python has made our virtual environment, I'm going to quickly go and activate that. So now that our Python virtual environment is enabled, all that's left to do is install Pillow to get these 2 Python scripts here to work. As you can see, it's a very simple, pretty much copy-paste command, which I think I'm going to do right now. I'd rather not type this out just to speed up this video. There we go. Once that package is on, we can actually open these files right up. To do so, as you can see, I got the package installed. All we need to do now is type in Python and then put the name of the Python file. In this case, since I don't have a picture to de-encode, I'm going to encode a picture with some simple text. If you're wondering, my Python scripts here that I made can actually encode files, but it's kind of finicky and experimental. I recommend just encoding text with it. But yeah, I'm just going to hit enter on that. And I'll make this full screen for you guys now so you can see what's really going on. It will ask you for a path. This path has to be very specific. Make sure it points to your image. In my particular case, the picture in question that I want to modify is this v.png image. So I'm just going to paste a directory for that folder, type in v.png, then hit enter. It will then ask you to either hide text or a file. You can select by putting either T or F in and hitting enter. I'm going to put text in because I don't really have a file to hide in there at this point in time. With that said, I'll type in "this is a demo for the video," and then I'll hit enter. That message will then be input into the least significant bits of our image, and once it's done doing that, it will ask us to then output the image. I kinda did my best here so that it would make a new file and not overwrite your old file. I did this so that you could preserve the integrity of the original file, so you don't end up having to resource another image every time. So I'm gonna just call this one how about capital OUT dot PNG. I believe I have to give it the file name. And yep, I was right. Okay, so be sure to finish it with the .png. Once that's done, I can now minimize my terminal. We can see that we have a new image. This image, if I were to open it up in, I believe this is Eye of Mate, and if I were to open up the other image, you should see visually no difference. Also, I know I'm hiding the data, or in this case text, in the least significant bit for the red channel, but even a picture like this where you think there's nothing but blues, the blues are comprised of other subpixels, so there's always going to be some form of red, green, or blue in your image. Another thing to note, our file sizes can change in size slightly, so the more you hide in your image, the more noticeable it can be, but overall, compared to some of the other methods I've seen, the size increase isn't that vast. So alright, now that we got our encrypted image, how would we go about decrypting it? Essentially, it's just the same process but in reverse. I was originally going to combine these two scripts into one single script that can do both functions. However, I'm not that good with Python encoding and decoding and stuff like that, so I decided to keep them separate so that they don't get confused. Anyway, to run the decode script, it's pretty much the same process as we did for running the encode script. All we need to do is type in Python, then decode.py, and hit enter. From this point, we just need to put the link to our image in our terminal. In my case, it's in this LSB encoding folder, and the image in question that we want to decode for our message is called vout.png. I'm going to hit enter on that, and it will just spit out our text in plain form in the terminal. If you're wondering if you happen to have hit a file in your image, it will actually ask you to save the file as a format, so that's pretty convenient. I'm glad I got that function to work. So if you happen to, let's say, hide a zip in the least significant bit and you want to output it, the program here, the decode script, will actually just ask for a file name. I don't even think you have to give it the extension, but if you want to, I think you can. You just hit enter like before, and it will just spit out a file with our, decrypted file. That's basically it for how you would encode and decode a file. Like I said, it's not perfect. Normally you would lock the actual contents of the file you're hiding within the least significant bits, whether it's through PGP or just some other form of locking mechanism. It'd be up to you. However, before we leave this off, let's throw my custom encoded image into a online least significant bit checker. There are a few sites that can do this, and most of the sites I've thrown my images into tend to not kind of work, but there are a few that work really great. This is one of them, and it even asks you for a password if you happen to have included a lock on your file. In my particular case, I don't, so I'm just going to upload that picture and hit submit, and it should just spit out our message, and it will actually show us the different values for the red, green, and blue channels, and we should be able to even select between them. As you can see here, this is what the program actually sees and looks for when it comes to decoding these images. Also, this site's really cool because if there happens to be any kind of other steganography involved in the image, it will probably find it as well. So if I just scroll down here on the site, it should be under the zsteg section. As you can see here, this is a demo for a video. That is the exact message I have inside this file. But yeah, that's basically it for the video. If you happen to follow along and you've downloaded the demo project, just keep in mind if you upload these images to different chatting apps, the compression can actually ruin the significant bit encryption we did, so it's probably better to send a direct link to the file or send it as an attachment. But yeah, for now, I'm going to leave today's video off here. DTPK signing off. Peace. Had a bunch of files that will go into our cache directory normally. Well, you can specify that and navigate to where our game is at. In my case, I put it in a folder called ROMs.